Okay, so now we are starting the first module, Introduction to Java. So what are the objectives of this module? Well, basically the module is there first to tell you exactly what is the reason you should be working in Java. So that covers what are the advantages of Java and where it is used. After that, we are going to talk a little bit about memory management in Java. Now, the interesting thing about memory management in Java is that you don't need to know about it. Okay. But having said that, it's very important that when you're working in Java, and particularly if you're working in development, to have a very inquisitive mind and a very, to know the details of things. Detailing is very important when you want to become a good developer. So many developers think that, okay, I'm going to Google, I'm getting the code, I don't need to go beyond that. Sometimes it's better to have a deeper understanding. And that's what separates the great coders from, the people who kind of just code and don't do anything, beyond that. We will give you a short introduction to Eclipse. Eclipse is a development environment, integrated development environment, and it's very popular when it comes to Java because it's open source and widely used in the industry. Then we are going to work with some conditional statements, if else, and we'll study various data types in Java, and then we'll be doing the looping statements. So basically, about half the lecture is on an introduction to Java, and the other half is some basic statements in Java. So do a little role play out here. John is a student, like you will play the role of a programmer, and the first thing you're doing in class is seeing what are the various languages. So if you look at the languages, you have C, C++, Ruby, Python, Java. The first four of these languages are very popular in colleges. So most college courses, they would be teaching at least C and Python. These are very good languages when you're teaching data structures or algorithms. So many college students will know them. Java also is very popular and it's taught in many colleges. But that's basically its popularity of Java is more in the, in real life applications and than in the universities. So why should you learn Java? Okay. So Java is highly secured, it's object oriented, and it's most widely used in the industry. So just give me a little feedback here. In your opinion, which of the three, I'll just give each one a number. 1, it's highly secured. 2, it's object oriented. And 3, it's widely used in the industry. Just type in which of, whether it's 1, 2, or 3 that that really motivates you to learn Java. Just type it in, just type your response. Okay. So widely used, okay. 2 and 3, it's object oriented and widely used. Okay, that's good. So widely used is good. I mean, particularly for freshers, if you're in the job market, then, obviously want something that's widely used. And the other thing is that if it's widely used, it means it's probably one of the most stable languages, right? So we are going to investigate further and see what else is there that motivates you to learn Java. Okay, so let's see where is Java used. Okay, John goes home and He's talking to his brother. He's still a little bit confused because no concrete, I mean, we've said it's widely used, but there was no real concrete examples of where Java is used that was given to him. So he's sharing his disappointment with his brother, and his brother says, okay, let's go and see where Java is used. Now, any of you can tell, can identify any item in this room which uses Java? Well, let's look. It's got a lamp, it's got some pictures, it's got a chair, it's got a carpet, it's got a TV, and it's got a set-top box. Which one of these you think uses Java? Okay. So yeah, it's the set-top box that uses Java. And in fact, it's interesting to know Java actually has a specification, JSR 242, for set-top boxes. So we would probably see a lot of set-top boxes that are interoperable in the future. So Java community process, they've already created a specification for set-top boxes, and that's good news. Then you have the GPS system. So I think even if you don't have a GPS system in your car, you probably have one in your smartphone. And in all likelihood, of course, in US, Apple might be very popular, but Android phones, which are basically a Java-based operating system provided by Google, that is more popular in many countries, and the GPS runs on that. So basically, Java is used in a GPS system, and many GPS system for cars also run on it. There are many other things in cars which is done by Java in the more advanced vehicles. Okay. If you go to a grocery store and there is a billing machine, it's quite possible that it's running on Java as well. Java is pretty good in the retail industry. Okay, so as you can see, Java is everywhere, and you'll find it bank tellers, ticketing systems, all of them are running on Java. Okay, so John goes home and he gets a gift. Oh wow, it's a mobile phone, Android. So it's great. I love receiving gifts like this. Haven't received one for a long time though. But yes, the Android, as I mentioned earlier, is an operating system, Java-based operating system developed by Google. And it's probably the most popular operating system on phones today. The other systems would probably be Apple, BlackBerry, and Windows has its own version. But by and large, Android is the most popular. Okay, coming to the Java programming language itself. So what are the main features of the Java programming language? Number one, it's concurrent. That means it can handle a lot of users. And the main challenge, if you really look at it, in the old days they had a system which, your computer was in a special computer room and there was a computer operator or someone who actually used it. Today the scenario is totally different. You may have sites like Amazon where anyone can go in and you'll have thousands of users. If you're working for a company, in all possibility, there would be a HR system where when you take leave, you'll go online and apply for leave. If you have expenses, you'll go online and you'll submit those expenses online. So the system has to cater to multiple users at the same time. So concurrent is the ability to handle multiple users at the same time. It is class-based. So we'll cover this in more detail in the third or fourth module. But yes, Java, everything is based on classes. It's object-oriented. This is as opposed to being a procedural language. And I'll take the object-oriented part a little more seriously, because what I've seen is in interviews and all that, there are a lot of people who still code in a very procedural way. And I've seen that there are many companies who are rejecting people because despite using Java, their code is very procedural and it's not object-oriented at all. So in Edureka, one of the things we do is to make sure that when you code, you're going to be coding in a very object-oriented way. And it's specifically designed to have as few implementation dependencies as possible. So this means that when you are actually working, there are many other classes, many other modules interlinked. When some changes are made, they should not break. Okay, you cannot overcome this 100%, but Java does provide a lot of features to make the dependencies as minimal as possible. So where is Java used? It's used in 850 million PCs. Okay, so that's a number. There are so many PCs in the world. Even such a huge number may not impress you. So let's go to the next point, Android applications. So Android, as you know, is an operating system of smartphones. Today, the web is moving more and more away from the PC environment into the smartphone environment. People do huge B2C companies are trying to reach out to users using the mobile phone instead of using the PC. And Android being one of the most popular mobile phone operating system, it's become a target for most of these enterprises. So mobile applications on Android. It also is used in Hadoop. Hadoop is basically something that provides in a clustered environment. You really want to handle distributed large data sets, okay, and you're going to use hundreds of computers for it. So the whole idea is that, if you use one computer, you won't get sufficient processing power. You can use hundreds of computers and use the spare processing power of these computers, and it has become the standard for processing large data sets. So if in the field of analytics, Hadoop probably forms the base. Everything that you do for large data, or what we call big data today, is done on Hadoop. So just think of it. I mean, how the world is changing. Yesterday, a couple of years back, all we were interested in, I have a program, it puts data in a database. I want to analyze that data. Today, what you want to know is the trend. People are talking about things on Facebook, on, there are some conversations taking place on LinkedIn, there's Twitter. I want to know what's happening and gauge a sentiment based on certain words. When you want to do something like this, then you need to use something like Hadoop. Telecom companies, nowadays their data is in terabytes, and conventional databases cannot handle it. Now, they have very challenging questions they want to ask. They might want to ask, in the past they may just want to ask, they would have asked something like, who's my best customer, how many corporate customers I have, how many individual customers I have, what is the, can I have 5 slabs, people who use below 1,000, people who use above 1,000, 1,000 to 2,000, like that. But today they're asking more challenging questions. They're asking like, which customers do you think are going to switch? which customers I should offer a promotion. They want to sell their data to other consumers. You might be a pharmaceutical company and you might be selling nutraceuticals, and the telecom company wants to look into its database, and the pharma company has something that, okay, this product of mine is a sports product. I want to target a certain age group in it, or a certain income level in it, and they want to profile people based on their interests, so that they can have targeted marketings. And it's very big business today. It's $1 billion industry. The data of telecom companies is probably their biggest asset, and they want to monetize it. So applications like Hadoop are very, very big, and it's the next big thing. So today the most happening field is analytics, and Hadoop forms the base of that. Then you have business process management. So what is BPM? It's a systematic approach to making an organization's workflow efficient, basically. Okay. And when we talk of it, we really look at it, like I said, I work in the extended enterprise area. So that means people want to extend their business workflow to their customers, to their vendors, and have one system that runs through and through. So that is something that's very, very important right now. So our architecture, basically, when we talk of services, we are talking about applications that map to business processes. And SOA has become one of the main architectural patterns that are used today. And then, of course, Java is used to develop web servers and application servers. So these are basically used by the Java community to deliver various applications. So coming back to some of the popular frameworks, so Android was an operating system, Hadoop is a framework, Spring is another very popular framework. It started off implementing what we call the dependency injection pattern, which is one of the best practices that are related to Java. Now it has Spring MVC. It has implemented the MVC pattern. It has this DAO, and basically it is one of the most popular Java framework. It's a pretty comprehensive set of frameworks. It's got the AOP as well, which is aspect-oriented programming, which is used for security, logging, transaction management. We'll be coming to Spring in a later part of the course. Hibernate is an ORM tool. It's probably the most popular ORM tool. That also is included in our course. And we have struts. Sorry for the misspelling. It's actually STRUTS, not STRUCT. So struts is one of the oldest, most mature MVC frameworks. Since we are covering Spring MVC, we will not be covering struts in the course. A couple of interesting graphics out here. So if you look at this, it indicates the various countries and their demand for Java professionals, and you can see probably the US and UK, US leading the demand, and the UK and a bit behind out there, but the demand for Java is very high. And you'll find there is a lot of demand for even very freshers with just 1, 2, 3 years experience. In fact, 3-4 years, there's a lot of openings for it. It's just the first 2 years that there's a bit of a struggle. You'll find the statistics interesting. And then there are various other Java technologies in the bottom. right hand side. So these keep changing, of course, and you'll find there's a huge number of technologies. The roles that you have for Java, you have Java developer, you have Java engineer, Java architects, so programmers, Java leads, analysts, and consultants. So you'll find these are some interesting figures which you'd like to go through. It all basically indicates one thing: there's huge demand for Java professionals in the market. So let's start our discussions on Java, but by trying to see exactly what is the problem that Java was trying to solve. At the time Java emerged, there was C, C++, Visual Basic, and Python. Okay. C, C++ was and is still pretty big on the market. Visual Basic now has become part of the .NET framework, but that was more of an event-driven programming in which it was very easy to code in Visual Basic. Python has remained more for academic, and it hasn't really caught on very, in a big way in industry as such, but still it's been more popular in academic circles. Java was basically to come up, I won't say to replace C++. It came up as an alternative to C++, and it came up with, a different outlook from C++. So you'll find many language constructs and all that the same, but you'll find that there's a certain outlook, that Java has that C++ differs. So one is C++ does not provide efficient garbage collection. So this is all part of the memory management. Okay. So the first point and the last point, memory allocation, deallocation in C++ was done by the developer. Primarily, this used to create a lot of problems in programs. So, okay, in a ideal world where every developer is good and everyone, doesn't make mistakes, that it's fine. But the reality is bugs and mistakes continuously keep happening. And C++, the way it handled memory could cause programs to crash, and sometimes not just the program that you have written, but maybe some other program. So Java actually took a different and more safer approach to ensure that programs did not impact the memory used by other programs. So Java memory management is quite different. We'll be coming to that. C did not have a built-in support for threads. So basically what threads are, Java provides a capability of running from your code, running 2 or more programs simultaneously. So initially C++ did not have this, but that capability is there with Java at that time. And C++ did not have a very rich graphic interface libraries, and Java provides that. And then C++ is not platform independent. So Java actually wanted to be platform independent, means once you have compiled the code, you should be able to run it either on Windows or Unix or Linux or any other operating system. So basically Java is platform independent. That means it does not depend on the underlying operating system. Java was basically something developed by Sun Microsystems, and James Gosling, he headed the project. It's platform independent, which means it runs on any platform. So as you can see, we've had regular releases of Java. It's from 1996, 97, 98, and then 2000, and later on started with every year a new release, then every 2 years, and now the releases become every 3 or 4 years. But even in 6, you'll have 6.1, 6.2, you'll have many releases over there. The latest release is 8, and it's still in beta phase, but it appears to be quite stable. So it's important to know that when Java creates a new release, it's part of the Java community process where the Java community basically makes suggestions, they are prioritized, and then they are evaluated, and then they see which are the suggestions that are worth implementing, and then they are prioritized and they are put into the next release. So what are the main features of Java? It's simple, secure, robust, portable, dynamic, multi-threaded, object-oriented, and high performance. Okay, the graphic talks about platform independence. So yes, earlier, everything was very proprietary, and people tended to have languages that just ran in one OS. Java, from the very start, is a community-driven open source language, and the intention was it could be used on any operating system. I'll come to each of the features separately in different slides. Okay, the first feature, platform dependent. So, okay, if you look at C++, I think those of you who have used other languages or who have studied, any sort of IT or computer science in college will be aware that when you write a code, you use a compiler, and the compiler will create an executable file, or if it's, or a shell script or whatever. Okay. So these files basically, after compilation, it creates a file that is understood by the underlying operating system. And because the output of it is a file that's understood by the underlying operating system, it means that every time you have a different operating system, you need to compile it. Okay. And very often, many of the features also, language features may be operating system dependent, which makes it difficult for those languages to run on more than one operating system. So you have source code, it compiles, and it gives you an executable file depending on the operating system, but basically that's a file that is understood directly by the operating system code. Java is slightly different. So you notice the key difference with Java is that you have a JVM, which is called a Java virtual machine. Now each operating system has the JVM installed on it. So you have the Java virtual machine installed on the operating system. And then what happens? The Java code that you write, when it is compiled, it creates Byte code, which is a .class file, and this .class file is understood by the JVM. The Byte code class need not be understood directly is not a class that can be directly understood by the operating system. It's the JVM that runs the Byte code class. Notice the previous file, that each of them after the compiler runs directly on the operating system, and in Java the JVM stands between the operating system and the compiled class, and that's how it's implemented independent of the operating system. Okay, so we said Java is simple. So So what do you mean when a language is simple? Just ignore what's on the screen. So let's take a look at some very simple features, things that make Java simple. First is in C++, you allocate memory, you have pointers, you move the pointers, all that. Java, the memory management is done totally by the operating system. All you need to do is you declare a variable. Java automatically allots the memory available for the variable and it manages it. If an object is instantiated, Java automatically will allocate memory for the object. You do not have to do it. So the memory management aspect that was there in C has been removed. Okay. What else is there? Java, basically, in order to make the language simple, it supports single inheritance. It does not support multiple inheritance. And it doesn't really lose much power by not supporting multiple inheritance. So this is another feature that makes sure that your code is very simple. Java also, when you look at the various Java frameworks, they have something called code by convention. I'll give you an example of this. Let's just say I have a table in the database called employee. Now, if I create a class employee, and of course I put the annotations that are needed by Hibernate, Java will automatically understand that that employee class is linked to the employee table, refers to the employee table. I don't need to write any code to associate a class with the table. Now, let's just say in the table, I had a column, ID, employee name, employee surname, date of birth. If in my class I have instance variables with these same names, Java will automatically associate them with the same names in the table. So when we are looking at Hibernate, this will be shown to you. But code by convention is something that makes your life very easy. You don't really need to write complicated code to link a variable in a Java class to a field or to a table in a database. Similarly, when you have forms, by following a certain naming convention, you will find that Java will automatically link them to the correct beans, to the correct variables and beans. So we'll find this something else, code by convention, that really saves you a lot of coding and it cuts down on bugs and it makes things very simple in Java. So Java has a very good security API. The language itself, because of the way it manages memory and other things, don't allow other applications to interfere with your application. It basically provides security at two levels. One, it has its own security API, and when it comes to web applications, it has a lot of security, particularly with beans and all that. Okay, so you'll find it has a lot of security features. So it's robust. So when we talk of robust, like we want an application not to fail. Okay, and it should be able to recover from errors. So Java is probably scores a lot of brownie points in that area. So okay, it checks code during compilation time. You'll find that the IDs also will give you a lot of information. If they find that certain code is not reached, you'll find warnings in the ID. At some stage, when I'm taking you through the ID, you will see the basic, you'll see these type of warnings, which I'll point out to you. Because of its memory allocation, and it's not leaving this, that was a source of a lot of bugs. And so Java's way of handling memory, instead of giving it to the coder, to taking that responsibility reduces a lot of application errors, making the application more robust. Portable. So when we say portable, it means it can be used across many platforms. And this has two aspects. One is, can you use the code across many platforms? And the other is, can your code be written in such a way that if I want to use it on a web, I can, the portion that I use on a PC and the portion that I use on a mobile, like there's a certain part which I don't need to change, and just I need to change the UI for both, right? So Java has a lot of frameworks that help you to do just that. So it's dynamic. So we'll look at some of these features out here. So we say there are many objects that are evaluated at runtime and execution is carried out. So one of the examples is runtime polymorphism. We'll also see basically certain patterns that are there towards the later part of the course, and these patterns help you, to write a lot of code that's dynamic out here. So basically, dynamic would mean that you don't declare some object at the very beginning and you're stuck with that, but you can select exactly which object you want. For example, if I'm using writing a payroll program, I don't have to have a certain type of employee right through. So I could have employees, and they may be permanent employees or contract employees, and basically as we encounter it by inspecting certain properties, we can in that employee class we can decide which type of employee it is. So you'll find various types of dynamism out there. It's distributed. So I did give you the example of Hadoop, which is very extreme, where you have huge data sets lying across multiple computers and computing across multiple computers. More traditionally, when we talk of distributed applications, we are talking of maybe of the same company. So I may have a bank may have branches, and each branch can have its own server, and these servers can be integrated at some other stage. Or more, a company, in fact, I worked for a pharmaceutical and distribution company, and they had manufacturing systems in Australia and Thailand, and they had a distribution business in maybe about 18-20 companies. So they would have servers in many places, like even they had in a place like Vietnam, and they had servers in Ho Chi Minh and Hanoi and 2-3 other places which are quite remote, and you cannot access them through VPNs, through lease lines and all that, because connectivity is not very good in those countries. But we could still have databases that in various cities, and we could actually combine them online at periodic intervals. Distributed can also mean when you want to make it more highly available, you use a cluster, so that depending on which server is available, you will send the request to that server. So I worked with a metro rail system, and that was real time. The responses had to come immediately because they are from various devices that communicate. So any signal received from a device cannot be missed, and these things had to be done. So we found Java very good in handling. So we would have a load balancer, and that would decide which server to send it to. So that's another strength of Java: distributed systems, distributed computing. Multi-threaded. So a thread is a task in a process or program. Multi-threading is multiple tasks running and executing at the same time. This facility is provided by Java so that many tasks can be executed at the same time. So if you look at your operating system anytime, okay, so you'll see there are many processes out here, right? So we say it's a multi-processing system. So you have Acrobat Reader running, you have Chrome running, I have Notepad running, I have many processes that are running, and all of these processes run at the same time. So similarly, Java can have multiple threads, and each of the thread is, in the context of Java, a process. And each process runs in its own thread. So one quick question. So why do we use multi-threading? So many people would say we use it to improve performance, because if I'm doing two tasks at the same time, it's going to be faster. I'm going to ask a question. I'll answer this in the class on threads. That, okay, let's just say I have a computer and it has one CPU, right? One CPU means I can execute one instruction at a time. I think if you worked on any type of programming language, you'll be aware, right? So the CPU can only process one instruction at a time. If your computer has 2, 3, then okay, maybe it can do 2 or 3 at a time. So why would threading be needed? Okay, so this is a challenge question. Just keep it in mind. I'll answer it in the multi-threading class, in the class on threads rather. But just see if you can figure out the answer in the meantime. But basically, threading is there to improve performance. How? That's my question. Okay. So it's object oriented. The importance of being object oriented. Okay, object oriented means everything is performed using objects, and objects are things that mimic real life. That's good. What is the importance of being object oriented as compared to being procedural or the previous paradigms, right? Well, in today's world, when a program is written, the main thing, the number one concern would be that someone else can change the program. So, in fact, earlier performance was the only thing we worried about. Today, performance may rank well below maintainability of code. Even in a project which has very, very strict performance parameters, still you would want your code to be maintainable. And of course, there is a good reason for that. Because if code is not maintainable, then all sorts, whenever you make changes, it becomes bulky and cumbersome, and you tend to copy the code just to make sure that the changes don't impact anything that's existing. And at the end of it, you get a very bloated code. So object-oriented is very important. And I can't stress this point enough. I'll say, today when we talk of an enterprise, the basic definition of an enterprise is something that's going to change. If there's one property that you have in an enterprise, it's that it's going to change. When we talk of management today, or when we talk of leading applications today, we want disruptive managements. People want to say, my application is disruptive. Earlier, when a person spoke of his application, he'll want to say, my application is very efficient. It will make you do this faster. You can process your orders in a few seconds. You can allocate your stocks, in minutes. Your sales vans can move out by 9 a.m. Even if the people have come in the evening, the invoices will be processed, and your sales van, I assure you, by 9 a.m. or maybe 8 a.m. in the morning, they can move out. Today, applications want to be disruptive. What they want to do? They want to say, I've shaken the industry and established myself as a leader. And every organization, if you see any bank, it must respond to anything its competitor does. Any telecom company must respond to anything its competitor does. If you're in the B2C space, if your website is not responding to challenges thrown by its competitors, it will disappear tomorrow. So change is something that is inevitable. We've even heard the term agile. How agile are you? How fast you can change? And when it comes to code, object-oriented code ensures that you can change very, very fast, that you are agile. If there's a disruption, you can respond to it and minimize the impact on your business. So object-oriented code is the most important aspect in all this. And finally, we come to performance. So yes, Java has a lot of performance advantages. We'll see it has many technologies. When I talk of performance, I just don't mean the speed at which code executes. I mean, let's just say two organizations are, communicating with each other. I just want to make sure that I'm sending a message to another organization. I don't need to wait for the response. I don't mind if the response comes later. Is there a mechanism for delivering the message later? And we'll see there are technologies like ESB and all that provide multiple ways of two organizations communicating with each other. You can communicate by uploading a file. You can communicate through messages. You can communicate through web services. You can communicate through HTTP calls. There are multiple ways where you can communicate to each other. The whole idea is that if I want a communication where I want 100% delivery guarantee, there is a means of doing it. If I want a communication where I want an immediate response, then there's a way of doing it. If the response fails and I don't get the response immediately, I can retry. Or, it's like a web page. If the web page doesn't load, you can retry it. But there are certain other communications you want 100% guarantee that it happens, like particularly when you're talking about communications made by machines to machines. Well, there's a way of doing that also in Java. So it gives you many, many different ways of communicating between systems.